2015 may be the year of Pluto, but getting there has taken many long years of effort. And for New Horizons, there's a date when things got started: 1989. It was the year when George Herbert Walker Bush became president and the Berlin Wall fell. Far from Earth, it was also the year when NASA's Voyager spacecraft flew by Neptune and returned the first images of its moon, Triton. Hairstyles of some New Horizons scientists were very different, but for them, May 5th, 1989 was a most important date.
That's the day that I marched into the then Division Director for Planetary Science at NASA headquarters, Jeff Briggs, as a graduate student, and asked him why we aren't studying a mission to Pluto. And he responded, because no one's ever asked me before. That seems like a brilliant idea. Why don't we do that?
Space missions rely on hundreds, if not thousands of people, but sometimes it takes someone with passion and persistence to make things happen. And for New Horizons, that's Alan Stern.
I was interested in this when I was a boy, so I've been somewhere between in the groove and stuck in a rut for 40 years.
There'd been some thought about sending one of the twin Voyager spacecraft past Pluto to complete the exploration of the known solar system. But in the 70s, the scientific establishment wasn't convinced Pluto was all that interesting. Young grad students like Alan, Mark Bowie, and Fran Bagenal thought differently.
Back in, about late 1989 or so, there was a bunch of us who were really keen to go to Pluto.
And the thing that drew me to it the most was the fact that we knew so little. Here's the frontier.
So it was a bit of an opportunity for young people to come in and say, hey, where are we going to go next? What's the next great frontier that we should go explore? And it was clear, out to the Kuiper Belt.
Alan, Fran, Mark, and a small band of enthusiasts became known as the Pluto Underground.
So we realized to make this happen, we had to get together and campaign hard to make the case to go there and explore this little planet with all its moons.
All through the 90s, there were many competing plans for a Pluto mission, like the Pluto Fast Flyby, the Pluto Kuiper Express. A Pluto mission was on, then off, then on, then off.
If the Pluto mission had been a cat, it would have been dead long ago because they only get 9 lives. And we've had significantly more than 9 stoppages and odd twists and turns.
What finally turned the tide was the National Academy's Decadal Survey, a consensus document from leading planetary scientists that ranked a Kuiper Belt Pluto mission highest in priority for medium-class budgets. Finally, after competitive proposals were evaluated, New Horizons, which teamed Alan Stern with the Johns Hopkins Applied Physics Laboratory, APL, and several other institutions across the country, was selected by NASA on November 29, 2001. Now, plans on paper became metal in clean rooms. In 2004, lead scientist Alan Stern described the mission's key science objective.
Well, you know, the key to planetary science is that you really have to go places to get the resolution, to get up close enough to really see what's going on. We want to get up close and personal.
The very best resolution of current telescopes looking at Pluto would give this kind of fuzzy image of a much more familiar world. But here's what New Horizons would see if flying over New York City. Lakes in Central Park, wharves on the Hudson River.
New Horizons is the first really of a whole new breed of spacecraft that is focusing on a very specific task.
For this first mission to Pluto, the questions are basic. What do Pluto and Charon look like? What are they made of? How do their atmospheres behave?
We had to really be disciplined and say, we can't do everything. Let's focus on the primary questions and design the instruments to answer those primary questions.
The long-range imager, LORRI, will be used for navigation approaching Pluto and close-up views during the flyby. The wide-angle camera, Ralph, has both visible light and infrared sensors to map Pluto and Charon and characterize their icy surfaces. There are 2 fields and particles detectors to probe the solar wind at Pluto. The large radio antenna is an essential communications device, but both REX and ALICE, an ultraviolet imaging spectrometer, are part of experiments to analyze Pluto's atmosphere.